What's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are tackling more SAT math problems straight from the source, straight from Khan Academy. And we are covering similarity and congruence problems. All right, let's get into it. Or congruence and similarity. Whoops, did I put that incorrectly? Yep, it should be congruence and similarity. So I wrote that backwards. I'll update that in the cover. All right, here we go. Question number 1. So we've got, let's see, two shapes. I assume they're similar or congruent. Parallelogram A, B, C, D. All right, so they're both congruent. They're equivalent. What is the value of A in radians to the nearest hundredth? Okay, so we got to solve for A, and it's got to be in radians. And these angles are already in radians. The key indicator there, as opposed to degrees, is that there's a pi value. So it's not 100% accurate, but there's no little degree symbol, so we're going to assume these are already in radians. Now, these are both parallelograms, and hold on a second, 5. Okay, so let me see if I can show you what I'm imagining here. They're both the exact same, and we've got, whoops, if they're both congruent is, by the way, just saying they're both equal. They're both identical. And they also have this like diagonal that's sort of drawn through, which means that this angle is equal to this angle, which means that this angle is congruent to this angle, okay? So I'm going to go ahead and say, let's zoom in a little bit. I'm going to go ahead and say that right here we can also do a pi fourths, all right? For this angle, I'll do double marks. And then if I know that, now here's the other deal with parallelograms. Oh, actually, hold on a second. I just thought of another way to solve this as I'm talking. These are two congruent triangles. When you take a diagonal through a parallelogram, like any sort of parallelogram, we take a diagonal across these two triangles are going to be congruent. I can prove that with here this angle, these two angles, this angle and this angle are congruent. I can prove that by showing you that they share a, let's see, how can I prove it? Angle, because these two lines are parallel. These are what's it called? Alternate interior angles. So angle, and then this is equal to itself, side. Anyways, whatever. You don't need to know that. But the fact is, these two triangles are equivalent. You could probably just tell. And so now, look, check this out. That means this angle is congruent to this angle, which means that this is also 5 pi eighths. Okay, now we've got a good situation because now we got a triangle, and all we're trying to do is solve for A. So that means that, and now again, we're in radians. So all the angles in a triangle add up to 180, but in radians, they all must add up to pi. Pi is equivalent to 180. So what we do is we say then pi fourths, which is this angle, plus 5 pi eighths, which is this angle, plus A, which is our unknown, equals pi. All right. Now I'm going to multiply this by 2 and make this 8. So I can combine these. Then I have 7 pi over 8 plus A equals pi. Then I'm going to subtract 7 pi, eighths from both sides. What am I doing? 7 pi eighths. I'll make this 8 pi over 8. Okay, this goes away. Now I can do 8 pi over 8 minus 7 pi over 8, which is just A equals pi over 8. And what is that all it's asking? Hold on. Oh, to the nearest hundredth. Okay, so we have to use a calculator. So it is pi divided by 8, which is 0.39. Okay, let's see if that's correct. Boom, it is correct. All right, excellent. Yeah, so see how they copied that over there? And let's just see if they did. Yeah, they did the same thing. Because these lines, it's a parallelogram. These lines are parallel. These are alternate interior angles, so they're both congruent, whatever. All right. Next, the diagram left shows a rectangular billiard table with a width of 39 inches and a length of 78 inches. A player is trying to shoot the red ball located at point H into the back corner pocket D. So by bouncing the ball of R, X inches. Okay, everything is basically on the diagram. Here, let me do this. copy this over. And then the player knows that when the ball bounces off point RHRB, which is this angle, will be congruent to DRC, which is this angle. Okay. If the point B is the midpoint of AC halfway, oh, I hit erase. So this means that this is 34 here. I don't know if we need this, but this is 34. It's halfway in between. And the red ball is 15 inches above B. What is the value of X? So X is, oh, I see. Hold on. X inches from point B. Okay, so X is this distance, basically. Hold on, let's do it in red. X is this distance. Okay. All right, so let's see. Oh, okay, got it. So what's happening is we're creating two congruent triangles. That is the topic here, but so that gives you a little hint. But you see this triangle and this triangle, this big guy, are similar. Not congruent, but similar. Similar means that all the angles are the same. They look kind of identical, but one's like a miniature version of the other, right? So these two triangles are similar. And we can prove that by knowing, because we know that these two angles are equal. Actually, we know these two angles are equal, these two angles are right. Angle, angle. Yeah, that's a similarity theorem. So we know the two are similar. Okay. And now we can probably set up a proportion to equate these two triangles. So watch. I'm going to consider this my little triangle, this my big triangle. So I know that this side here is the same as this side. These hypotenuses are equal, but we don't care about those. So not equal, but sorry, similar. They're corresponding. So again, I do little triangle 15 corresponds to big triangle 39, just like this length here, which we don't know what this length is, because this whole length is 34, not this little length is here. So we know that for the, actually let's do the little triangle first. Little triangle is X, little side, over its corresponding one of the big triangle, which is 34 minus X, because this whole thing is 34 minus X, that's that other side. And then we got this, and now we can cross multiply and solve for X. So boom, boom. Well, let's use calculator. 15 times 34. 510. So we got 39x on this side equals 510 minus 15x. Let's add 15 to both sides. And I get 510 equals 54x. And then divide both sides by 54. Ooh. Whoa, whoa. What's going on? 54. It doesn't go in evenly. It's not letting me write down there. 54. So let's see. 510. Oops, I had it already. 510 divided by 54 is 9.4. So I guess it's about 9 inches. I hope I did all that math right. That's weird. It looks right, you know? So I'm going to roll with it. Darn it! I did some math wrong. Hold on. Before I look at the math, let me see what I did wrong here. 15 to 39 is equal to x for 34 minus x. 15 times 34 is 340 plus 150 minus 15x equals 39x. Add 15, 44, 54. 510 divided by 54. What is the value of x? How did I not set that up right? Hold on, let me think. Corresponding. X. I'm going to figure this out first. Hold on. 510 divided by 54. 510 divided by 54 is 9.4. Huh. How did I set that up wrong? Okay, hold on. There's a width of 39 inches and a length of 78. That's the midpoint. All right, let me try one more time. I'm going to set all this up one more time. Just see if I can catch whatever mistake I made. All right, so let's see. We got two right triangles. They're congruent. This is 34 minus x, and this is x, right? Because this whole thing is 34. So this must be 34 minus x is this length. Okay, so I got 15 to 39. This side over this side equals x over 34 minus x. Then it's 39, 44, 54, right? 39x equals 340 plus 170 is 510 minus 15x. And then we get 54x when I add 15x to both sides. I'm really confused. B is the midpoint of AC, right? I wonder what the answer is. It's 11. Portion that incorrectly compares the corresponding parts. 15, 15. Incorrectly compares the corresponding parts of similar triangles H, B, R, and H, R, B, D, R, C. So are they saying that this is okay? I really don't know. How is it 11? Let me see what they did here. Okay. DC over RC. Oh, they did a little different, but DC over RC, yeah, equals HB over BR. That's essentially what I did, but I did it like, you can set it up a different way. Hold on, let me see the values they put in. That whole thing is 39, right? That thing is 39 minus X. And then it's, how do they do 30? Did I? 585. 34. Oh my God. I know what I did wrong. That's the worst mistake ever. Half of 78 is not 34. It's 39. Oh my God. That's horrible. That's horrible. Okay. So that's why I just wasted all this time. Sorry, guys. That was really sad. Okay, so then everything else was set up correctly. I literally divided, should have just, that's a bad mistake. Anyway, so now we cross multiply and I get 39x equals, what's 15 times 39? 585, right? Yeah, 585 minus 15x. Then I add 15 to both sides and I get 54x equals 585. Divide by 54. 10.83 rounds up to 11. All right, it's pretty funny. That one really got me for a while. Okay, let's go on to the next one. Here we go. Question number 3. Given the figure at the left, so I'm going to do the same thing and copy this figure here. Let's do it like this. Okay, so given the figure at the left, which of the following statements must be true? AB is parallel to DE. Nope, didn't load. Hold on. All right, so which of the following must be true? Okay. Is AB parallel to DE? Let's see. This is 105. I'm going to fill in all the missing information that I can. These are vertical angles, both 45. This one is a vertical angle, so that's also 105. This is 30, 105. So this is 105, 135. This must be 45 because all the angles in a triangle add up to 180, right? So 30, 45. Oh, look at that. These are parallel. Because they have alternate interior angles that are congruent, this is my transversal. That proves that these two must be parallel. And look, 105 plus 45 is 150. This one has to be 30. That's another set of alternate interior angles that are congruent. So right off the bat, I know it's A, B. This guy's parallel to DE. Let's see these other ones just for fun. C is the midpoint of BD. No reason to think that. Wait a minute. Actually, oh no, these two triangles are similar. They're not congruent. So no, we don't know that's true. Triangle CBA is congruent. No, we know they're similar because of the angles. We don't know anything about the sides. ABC and ABC and DCE are vertical. No, ABC is this angle and DCE is this angle. Those aren't vertical. So it's that one. Okay, next. In triangle ABC shown at left, tick marks of equal number present of side lengths. Therefore, the point along segment AB is the midpoint of AB. What is the value of B in terms of A and T? I don't even know why I read that without looking at the diagram. Okay. Come on. AB is the midpoint. Therefore, the point along line segment AB is the mid. Okay, so these two are equal and they kind of marked it. B in terms of A and T. Okay. I believe. Oh, and this is all. Oh, these are three midpoints connected. And there's actually a theorem about this. There's a couple things. This is actually parallel to this, but it's a midpoint theorem. I don't think we need to know that though. Let's see how else I can put this together. And I think it's showing me that beta is equal to A. No, actually, I don't know if that's what it's saying. I think it's just saying that's an angle. No, they're not equal. All right. What happens though is that when we connect the midpoints, we create two similar triangles, all right? Because these are parallel. Okay, so actually it does help. There's a theorem that when you join the midpoints, the two midpoints of two like opposite sides of a triangle, you draw a line across, it's parallel, which means then if it's parallel, we have angle, and then this angle is equal to this angle. This is also alpha, okay? Because these are now corresponding angles, and then this angle is equal to this angle, all right? So we got similar triangles. And then now let's look at this guy. I think that this inner triangle, I believe, is congruent. I think these two triangles are congruent, but let's prove it. So, oh yeah, and then I'm joining these midpoints, and so this line is parallel to this line. So that means then that, let's see, I think B and T are equal to each other, actually. But that means then that if this is parallel to this is a transversal, this is alpha, this is also alpha, and this is also congruent to that side. These two are congruent. Okay. Now we're getting into an interesting thing. Now I can create two equations from this. It's a pretty hard problem. So my first equation is alpha plus beta plus some unknown x equals 180, right? These three. Oh, actually, and since this is all equal, actually, look, this is equal to itself, right? By, let's do 4 dash marks, because by the, what's it called? It's equal to, the line is equal to itself. So these two triangles are congruent by angle, side, angle. But, so I can say that actually B equals T. Oh, wait, yeah, B just equals T. these two angles are congruent. But I could have also proved this setting up these two equations. I could have also said, because this corresponds with this, but I could have said another equation, t plus alpha, for this triangle, t plus alpha plus this unknown, which I'll call x, also equals 180. Then we kind of got this system of equations, and then I can maybe make this whole one negative. Boom, 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 boom. Add the two together. The 180s cancel out. The x's cancel out. The alphas cancel out. And then I get negative t plus beta equals 0, and then isolate beta. Beta equals positive t. So that should be correct. Kind of a long way about it. I think if you readily spot that these two triangles are congruent, you don't need to do any of this. Just jump straight to that conclusion. Very hard problem. Okay, next. Let's take a screenshot. Come on, where is it? Diagram at left, line V transverses lines W, X, Y, and Z. Sure, means it kind of just crosses through them. Given the angle measurements shown, which pair of lines is parallel? Okay, I'm looking for congruent or supplementary, anything. Let's see, 96. Oh, here's how we do it. Okay, this is gonna be good. So we're gonna fill in all these values. So let's fill in. This is 84. This is also 84, right? Because they're vertical angles. And if this is 84, it's supplementary with this angle over here because they're on a straight line. So what plus 84 gives you 180? It would be 96. So I already know which two lines are parallel. It's got to be W and X because now I've got this corresponding angles that are congruent. That tells me they're parallel. But let's keep going just for fun. So if this is 85, this side over here is whatever adds up to 180. That'd be 95 over here. And then this is 94. This would, what adds up to 180, that makes this 86. 94, 86. 85, 95. So there's no other good corresponding angles. Look, 96, 95 doesn't match, 94 doesn't match. These don't match with each other. The only two are W and X that are parallel. Yeah, and I mean this angle here is 84 also. This is 96. You can also see with alternate exterior angles, alternate interior, this is also 96, so many ways. All right. That is it, my friends. Let's see if we got any questions. Nothing. Message is retracted. I wonder what that means or why. Okay, well, that is it. Thank you guys so much for joining. I hope that was helpful, beneficial, especially for you guys prepping for this August upcoming SAT. It's a big one. I wish you all the best of luck if you are taking it. And make sure to keep watching these videos and practicing with me. Definitely subscribe if you are prepping for this upcoming SAT. And make sure to like the video if you like it. Leave any questions or comments in the comment section. Thanks so much, and I'll see you all in the next video. Take it easy.